All right. So this one's kind of different because we are actually finding the final temperature. So they give you your total energy, which is 65.0 kilojoules. They give you a mass, and they give you an initial temperature. So we know that the freezing point of water is actually 0 degrees Celsius, so we know right off the bat there's a phase change. And since they're asking for a final temperature, we know that it changes from 0 degrees Celsius. There's no way it can stay at 0 degrees Celsius. So we have to go up. So that gives us Q1 down here, and then Q2 right there. So our first step is to find Q1. Q1, we have to think, okay, what equation do we have to use? It's a phase change, so we have to either use mass times heat of vaporization or mass times heat of fusion. In this case, we're using heat of fusion because we're going from a liquid to a solid, or a solid to a liquid, I'm sorry. And so we're using mass times heat of fusion. We can plug in our variables, which is 150 grams times heat of fusion, which is given to you on the front, which is 334 joules per gram. And we get 50 point, because we're saying that 0 is important, kilojoules. Again, sig figs, this has 2, this has 3, your answer should have 2. The next step is we need to figure out Q2. This is another one of those problems where they already gave you the total Q, so we can use Q total equals Q1 plus Q2. And what we're going to do is try to find that Q2. So we have to move our variables, so all we have to do is subtract Q1 from Q total. So you get Q total minus, minus Q1. And that is equal to Q2. And then we can plug in, so you have 65.0 kilojoules minus 50 point kilojoules. So your difference should be 15 kilojoules. Alright, so our last step is they're asking for that final temperature, and Q2 is the only segment that experiences a temperature change, so we have to use a Q2 equation. And again, Q2 experiences a temperature change, so we have to use MC delta T. Alright, so we'll mark this like the third step. And then, so we have Q2 is equal to MC delta T, which is temperature final minus temperature initial. Alright, and then we have to rearrange the variables to get temperature final by itself. So we end up getting Q2 divided by mass specific heat plus temperature initial equals temperature final. Again, here, like, I didn't just like make that up. I moved the variables, so you'd have to divide MC right here. So you get Q over MC. Oh, this should be Q2. Over MC plus T initial, because I got to move that over here. And then I'm left with T final on this side, like right here. So I plug in my stuff. I get so right here is another situation where you have to either stay in kilojoules or convert to joules. They give you specific heat, or C, in joules, so I'm going to make sure that my top Q2 is in joules as well. So it would be 150,000. Oops, I'm sorry, it wouldn't be 150,000. It would be 15,000. And then that's joules. Alright, so I got this by just taking that 15 kilojoules and multiplying it by 1,000, because that's our Q2. And then we divide it by our mass, which is 150 grams, times our specific heat capacity, and for water it's 4.18 joules per gram. All right, a huge thing here, guys, you have to make sure that your units match. If this is in joules, this has to be in joules. If you want to do it in kilojoules, then by all means convert this one. You just have to keep track of your units. We won't trip you up too much on the test, but it's something to keep in mind. Alright. And then plus, we need that initial temperature, which actually happens to be 0 in this case. So we can do that. And then when we multiply these together and divide, we actually get an answer of 23.8 degrees Celsius, and then we have to look